All right, it's time to shake things up a little bit. To this point, we've been dealing with a pretty simple, straightforward model, just our one data table, that sales data table, and a bunch of individual lookups that we've created connections or relationships to. Now, here's the thing. I just got off the phone with our client at AdventureWorks, and it turns out that they have another data table with information about product returns that they'd like us to integrate into the model as well. So in other words, they don't just need us to analyze product sales, but they want to get a sense of which products are being returned most often as well. So what we're dealing with here is something like this. In this particular case, we've got a simplified model with 3 lookup tables: customer lookup, calendar and product lookup, and 2 data tables: sales data and returns data, each with its own set of dates and other foreign keys. But take a minute and look at the relationships here. What you'll notice is that the sales data is connected with one-to-many relationships to all 3 of the lookups: customer lookup, calendar, and product lookup. But the thing is, the returns data is only connected to the calendar and the product lookup. We don't have any way to connect returns data to customer lookup since we don't have a foreign customer key. And this isn't entirely uncommon, especially for larger or more complex real-world models where you're pulling in data from a number of different sources. It's actually quite uncommon to have the exact same set of foreign keys in every source data table that you're working with. So this is the type of scenario that you may very well run into in a real-world application. So what this means is that we can analyze sales and returns data, sales quantities and returns quantities, within the same view or visual in Power BI, but only if we filter or segment our data using fields from shared lookup tables. So looking at the returns data in this particular case, we know which product was returned because we have a product key, and we know which date the product was returned because we have a return date, but we know nothing about the customer who made the return. So there's no way we could slice or dice or filter that returns data by any field in the customer lookup, like names, marital status, gender, income, any of those fields. So what you may be noticing here is that we've successfully integrated that returns data into the model, but we did not attempt to make any kind of relationship between the returns data and the sales data. And the reason for that is that no matter which fields we tried to use to form a relationship between those 2 data tables, we're always going to run into a many-to-many relationship error. And that's because both data tables, sales and returns, have multiple dates in the date field. They have multiple products in the product key field, multiple territories in the territory field, and so on and so forth. So even if we wanted to connect those 2 together, there'd be no way because we have no field that would give us a valid one-to-many relationship. So that's a very, very important point. Generally speaking, you will never create direct relationships between data tables. Instead, you connect them indirectly through shared lookup tables. So what we're going to do now is jump back into Power BI. We actually have that returns CSV file that we're going to load up, and then we're going to wire it into our model, creating relationships just like the ones you see here. All right, so once you're back in the relationships view of your AdventureWorks report, go ahead to the Home tab and click Get Data. We're going to get our last file of the project. It's another CSV. And this time we want AdventureWorks_returns. So go ahead and double click. Take a look at the preview. Pretty simple data set here. Got a return date, a territory key, product key, and that numerical quantity field as well. So let's edit this file to fire up the query editor. And first things first, let's head to our table name and call this one AW returns. Check our headers. They're promoted. We've got dates for return date, whole numbers for territory key, product key, and quantity. Very straightforward. All looks good. Let's go ahead and just close and apply just like it is. And we'll see that object pop in right here in our relationship view. There we go. So here's our second data table. I'm going to kind of click and drag and make some room for it here. And I want to make it clear that these 2 tables here are the 2 data tables that we care about. Now remember, I can't just grab a field, a foreign key from my returns table, and try to force a connection right to my sales table, because I'll get that many-to-many relationship error. You can't create a relationship because one of them must have uniques. So press OK, and the same holds even if I try to use my keys. Territory key to territory key, can't do that either. So again, the way that we integrate a second data table, or a third or a fourth or a fifth for that matter, is by wiring it in and creating the same relationships just like we would with any other table. So territory key can connect to territory key, return date can connect to calendar date, and then last but not least, product key can connect to product key, and by association, product subcategory and category as well. So again, no customer key means that we can't form a relationship with that customer lookup table. Now, to really hammer that point home and understand how this impacts our analysis, let's jump all the way back up to the report view. And as you can see, we've still got our matrix here showing product name and order quantity. So what I'm going to do is select that matrix. You can see my returns table has populated here. I'm going to grab return quantity and pull it in right under order quantity in my values. And I can expand to view and take a look. This looks great. I'm now seeing order quantities and return quantities side by side in the same visual, broken down by product name. So that's really helpful, and I can get a lot of insight from this. But what if we want to see this same view, these same values, broken down by gender instead? I'm curious if men or women tend to return items more frequently. So instead of product name, let's pull that right out of our matrix, and let's go ahead and drill into our customer lookup. And right here we can find gender, pull that into rows, and take a look at this. We see the order quantity, which seems to be correct, but for return quantity, get that same repeating number issue that we've seen in the past. And almost every time you see that repeating number issue, it's because of a relationship problem. And in this case, the relationship problem is that we're trying to apply a filter from the customer table and show values from returns, which is an unrelated, disconnected table. And that goes back to the point that I made earlier. You can only view fields from both of these data tables in the same visual when you're filtering or segmenting using a field from a common or shared lookup. Since the customer table is not shared by both of these, this is an invalid view, and that's why we see these duplicate, erroneous values. So let's jump back to our relationships view. And this is our finalized data model. So we've got all of our tables in here. We've got all of our relationships in place. This is going to set us up for some really interesting analyses down the line. But before we move on to calculated fields with DAX and then visualizations, we need to hit one more really important concept when it comes to data modeling, which is the filter flow. So stay tuned, that's coming up next.